Okay, good morning. Again, so this is a continuation for those who are not using a calculator. So if you are not using a calculator, you're using Google Sheets, please go ahead and switch over and stop the video and watch a different one. I'm gonna try to be to the point so you'll have optimal time to work on your assignments. Okay, so the first thing, these problems are lengthy. So the first thing you really want to do is label and write out everything. And one thing I really do love about Google Sheets is that as soon as you have it all set up, you never have to set it up again. You just fill this purple and yellow boxes, and everything else will take care of itself. You'll never have to worry about it ever again, which is, like I said, pretty awesome. I think you're the only one on this one you're gonna have to change. It's probably this guy right here, and that's it. Everything else should be based off of what has been previously done. Excuse me. So as you read this problem, I want you to be essentially filling in all the information as you go. So this example is about small and large nursing homes. Well, let's just read it and get through it. A nursing home study mentioned in chapter opening statistics today, researchers found that 12 out of 34 randomly selected small nursing homes had a vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate of less than 80%. At an alpha of 0.05, test the claim that there is no difference of proportions for small and large nursing homes with a vaccination rate less than 80%. Okay, so the first thing we're going to knock out is we're going to do a confidence interval, because that was one of our goals. So in setting this up, you'll see I have my proportion 1, which I went ahead and labeled as my small nursing home. So that is 12 out of 34. My Q, which we're going to need for the calculations, it's not mentioned in there per se, is simply just the 1 minus that. And then my sample size in X1, I had to pull all these in here because I will be needing them for calculations. Same thing up here. My P2 is my proportion 2, which represents my large nursing homes. 1 minus that is that value right there. There's my sample size, and then the number of nursing homes out of 24. Okay, so because this is a proportion, I do know a few things. Since our alpha is 0.05, that means my level of confidence is 95%. That being said, from a previous lesson, we know that our critical value is already 1.96. Our standard error, what I did here is I used a formula from our formula charts. It's essentially the critical value times the square root of p hat, this is what B3 is, p hat times q hat divided by our sample size plus p hat times q hat divided by sample size. And you'll see that right here. The square root, it's the critical value times the square root of p hat times q hat divided by sample size plus p hat times q hat divided by sample size. That's there. Let's see here. And this is the difference between the two sample sizes. Now, I went ahead and made sure it was absolute because you definitely want to make sure you want to do the bigger minus the smaller. But if you do absolute value, I actually don't think even we need to worry about that. So that's what I went ahead and did here. So I did an absolute value, which is what ABS means. So I didn't have to think about that. Now the next thing is to find your actual confidence interval itself. You simply do the difference in proportion, which is the value, minus the standard error, which is this value right here. This is B10 minus B9. And then you define the upper bound, you do the addition version of that. And then the way you interpret these values is I have down here. We are 95% confident that the average difference of vaccination rates for large and small nursing homes is between 11.3% and 59.8%. It's straightforward, and that's it. Okay, that's how you do a confidence interval. Now, I will say setting up a hypothesis test for proportions is going to be a little more interesting than for an average or a mean. It took a little bit more work, but I'm confident y'all will get it down. Like I said, though, once you get it down, it comes very easy from in the future. Okay, so the first thing I do is I state my null alternative. Now, the null alternative for two proportions or two means is going to be different from what we did in Chapter 8. In chapter 9, your null is proportion 1 equals proportion 2. Remember, your null is always equal to. It's the status quo. Alternatively, you're saying, is there a difference? If you read the problem, it says, is there a difference between proportions of small and large nursing homes? Well, that's what we're testing, so that's our alternative. It's P1 different from P2. Our level of significance is 0.05. I typed that in there. There's no formula for that. If you really wanted to, you could put equals 1 minus confidence interval. It's the same thing. Now, P bar. This is something you're going to need for calculating proportions for proportion tests. If you have your formula chart, if you look on chapter 9, it'll explain the formula in detail there. So if you have your formula chart, well, you go to Google Classroom, look at it. I have it there for you. So P bar is x1 plus x2 all divided by the sum of the sample sizes. You add those together. That's what you can see here in the formula, and it equals 0.5. You're also going to need Q bar, so the complement to that, so which is 1 minus up there. And definitely want to do the formula for this because it will automatically do it for you in the future if you need to. Because the denominator was a bit complicated, I went ahead and did the denominator separate from the test statistic. Once again, you usually want to do the absolute value here. It makes the calculation a little bit easier when you're doing this. So if you want to, I could say equals the absolute value of 0.033, but it's going to affect my formulas down here. I don't want to mess with that at the moment. So that is the difference between, usually, like I said, bigger minus smaller, or if you want to do in the future, you can push absolute value by there and it'll be fine. Critical value, I have it as equals B8, so I'll only type it in once, and there's my p-value. The way I got that p-value is using this formula, normal distribution of B22, which is our test statistic, 0, 1, true. True meaning it's cumulative. And then I'll do an additional formula here. If you want to do it, you can. If you don't want to, you don't have to. I found it easier to do an if formula. So I put equals if B24, the p-value, is less than an alpha of whatever my alpha is, wherever I type that in at, 0.05. There's that. So if this is true, comma, what do you want it to say when it's true? Well, if it's true, in quotations, you type in the reject null hypothesis, comma, if it's false, the same as false, and it's the other way, it'll automatically say this. So I have an if statement, so I can essentially do all this calculation, and at the end, Google's going to tell me automatically whether I reject or fail to reject, which is, I think, a little nicer. That's what I'm thinking about it so much. You have a lot of front thinking, but at the end of the day, the problems will be a lot nicer at the end. So the way we interpret that at the end is down here. Since the p-value of 0.04 is less than alpha of 0.05, we reject null hypothesis. There is sufficient statistical evidence to suggest that there is a difference in vaccination rates in small and large nursing homes. Now, the other thing I want you to think about is, what does it mean to you? Well, for me, that this means is that I may not want to send my potential grandmother or maybe mother eventually that to a small nursing home. Why? Well, because this right here tells us there's a difference in vaccination rates. If you go further, you'll be able to tell that there is that small nursing homes have a smaller vaccination rate than large nursing homes. Large nursing homes are better. And that's just the way it is. So personally, I would rather send a potential, if I had to send somebody to a nursing home, I'd send to a larger one. But that'd be my personal opinion. Okay, so jumping into the next example here. So actually I'm running low on time. I'm going to go ahead and pause the video. The next two are going to be set up very similarly. It's going to be very minor differences. So in this next example, you'll even see that I highlighted the differences. So I didn't do a lot of extra work. So the next video should be relatively short.